Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk.
Hey, Fred.
According to my little cheat sheet here for keeping track of recordings and stuff like that, this is going to be our 750th episode.
That you and I've done?
Well, it feels like it doesn't, you know. No, that the show is done.
We average about 2 a month, right, for you and me. That's typically.
Yeah, so you got a quarter of them. So you're, we're in well over 100, 150 or something like that episodes.
But I have episode number 1, and nobody's going to take that from me.
No. Well, I don't know. iTunes kind of does because they only show the last 100. So.
Really?
You have to really dig to go further back in the list.
Yeah. I'd say most of it's still good material.
Oh, yeah. Good. Because it's not usually dated or anything. Once in a while, we talk about a current event. But most of the time, it's green. We call it Greenfield or Greenpeace. That's not the right word. Whatever. But hey, what better topic to talk about than the decisions or the lack of decisions to say something should be shipped or not? Is it? And one of the criteria that we have lots of evidence on is it safe? And you sent me something the other day, this piece of medical equipment saying, we don't really know what's wrong with it, but if you take the batteries out and reboot it all, well, and by the way, this is time sensitive. I imagine this medical device, sensor, meter, whatever.
It's like glucometer. Yeah, it measures your blood sugar.
Yeah, and it's like, what in the... And we were talking about, and I've seen it myself in medical facilities, that a lot of this stuff just doesn't work. and then they have all of the oversight and controls and making sure that, the name matches the prescription, matches the dosage, and all this kind of controls in place.
Right. There's safety interlocks essentially for medical administering medicine, so that you don't give, the wrong medicine to the wrong patient, which unfortunately happens.
Yeah. Well, it's the same in a manufacturing line. When I worked on circuit manufacturing, you really don't want to put the wrong component in a spot, right? If it calls for 100 ohm resistor and you put 1,000 ohm resistor in it, it might make a difference. Or it could even be worse cases than that. And when you look at a reel of resistors, they are visually identical.
Well, sure. Right.
And there's paperwork and different production lines have, do you have two people look at it, or you have procedures to do it, or they're kitted in a certain way. But then it still has to work with the equipment. The equipment has to go, oh, I know what component that is and what dimension it is and where it goes. And if that's not working, you just make scrap really fast. And so operators were constantly in the program and updating stuff. And I've seen it in cable equipment facilities. I've seen it in auto machine systems. I've seen it in medical device construction stuff, sensoring equipment, oil and gas industry, everywhere. That we write a process, or we write a technique, or we create a product, and it's just not there yet. It's just, whether it's a process or the equipment itself, it's just not there yet.
Right. There's a learning curve usually with any new process or new setup, and with manufacturing and circuit boards and stuff like that. It is easy. It would be easy to mix up or leave a reel of one type of resistor, and it may be just it may not be that off in value, or, for instance, little MLCCs, that really, if you left them off, they may not make a difference at all. Some of them.
Well, it depends. If they're a decoupling cap, that's no big deal, right? In most circuits, but in a high-speed circuit, it's critical. Or if it's in an RC circuit, it won't work. It just won't be
That's true.
the circuit won't function.
Right. It depends on the application. It's just like in one of the major failures of capacitors in a circuit in a computer company that was, had 28 on the circuit board. Only 4 of those were critical. And if the rest of them, we actually did make all the other capacitors vent or get them to bulge so that they really were failing capacitors. But only 4 of the 28 locations were critical to the actual operation of the computer. Mm-hmm. I mean, turning it on and booting it up.
Yeah.
So, but because of the problem and because of the manufacturing defect that was unknown, the latent defect, they had to replace all 28 capacitors. Yeah. I mean, the engineers didn't feel comfortable leaving known defective capacitors, even though they didn't affect the operation of the machine, and they really wouldn't cause a failure.
You get one of those electrolytics, not just the bulge, but the vent. Now you got electrolytic solution all over the place, and that's just going to cause problems, and it smells bad.
It's a problem.
Yeah. No, so the bigger point here is I was talking to somebody the other day, and, there's tons and tons of latent defects or just things that the product goes bad, or you got to take the batteries out and reboot it, or you got to do this or that. But those may or may not be safety issues. But I was talking to Elise the other day, and she said, every single day there's an auto recall. And it's not a recall just for fun. It's a safety issue, right? Every single day. And some of them affect, just one day's production, or some affect hundreds of thousands of vehicles. And then there's medical device. FDA has a recall or warnings every day. And the Consumer Protection Agency has recalls every day. She says there's thousands and thousands and thousands a year. And those are safety recalls. They're not recalls because they're losing money on it. No, it's the government saying, no, you need to fix this and recall it. And her point was though, why do companies ship stuff that has a safety problem in it?
Well, the question is, do they know it? Because that's certainly a big liability issue.
Right.
And that's why their testing is usually very secret and proprietary and never released. There's a lot of
as well as I do is that the companies that we've run into, they're doing standards, and the test they're doing is we take 3 samples and walk it around the block and call it good.
Exactly.
But some of that is naivety, and sometimes it's, that only happened once, we're going to ignore it. But the point of decision that dawned on me, and in talking to Elise about this, was that, and you're familiar with the truth table, right? Where there's the real world, the product is safe, and when we ship it, it'll be just fine. And that's what we want to do. When you decide to ship it and people use it and it really is safe, and everybody's happy. And the other side of this is a product is not safe for some reason, and we've decide that it's not safe based on our testing and data, and the world is happy, and we go fix that and then delay the shipment. Those are both good decisions.
Right.
But the opposite occurs is that when we think the product is bad, let's see. We think the product is not safe, and it really is. Right? So what happens if we decide a product is not safe, but it really is? What would occur in an organization that said, we're not sure about this, we saw it once, or we have some data that shows it on the margin, we need to fix that. Right?
Well, I don't know, Fred. It depends. There's a lot of factors involved. How many units have shown that? Is it repeatable? Was it a manufacturing defect? Was it a design defect?
We have some evidence of any of those things you just listed that says, no, this isn't quite right. We got to fix this. But in reality, it's perfectly safe. It's fine.
Well, but we don't know that. The side of fixing it. I mean, if it's found and there's a fix that you can put in that will make sure that doesn't happen, even if you don't suspect it will ever again. But again, what's the root cause? What's causing this?
So you're going to go spend some money, and you're going to spend some time and energy. You might delay shipment, right?
Yeah.
But it was a safe product, and you then are able to convince yourself it's a safe product, right? With some additional work. So you spend some money and some time, and you go to it. Nobody gets hurt. No products get recalled.
You err on the side of safety, of
right.
course.
But on the other end of this is that the product is really not safe, right? It is not safe. There's going to be a recall coming. But we convince ourselves with the testing or data or the analysis we do that it is safe, and so we ship it. And I think you used an acronym earlier. It's acceptable to ship.
ATS, ATS.
And
I can't imagine any company knowingly ship a product with a safety issue, because the liability, depending on what that safety issue is certainly a human death or fire or destruction, any kind of safety issue, makes a company so potentially liable, especially if they know about it.
Well, in the U.S. it is, but but why is it that there are recalls every single day? Safety
because they haven't
recalls.
discovered it. I just recently took my Kia Soul. It's a 2018 Kia Soul. And so far, I've had 2 recalls on it, and I've only owned it, a year, 2 years, maybe. Okay. First one was an engine module update. Apparently, it really wasn't a safety issue because they just wanted to have a better monitoring for their computer of the engine, and then they would guarantee the engine for a lot more miles. So it really wasn't a safety issue. But the second one I just brought in this week, actually Friday, was a module in the ABS, the automatic braking system. Okay. So that was a safety issue because obviously we let almost every car today, or modern cars, all have automatic braking systems, which means there's a computer actually controlling the wheel's brakes. That you're telling a computer to stop, but the computer is saying, well, wait, this tire is still turning and rotating and this tire's not, and I'm going to, start, I'll let the brake off on that tire. So we actually we're relying on a computer. People worry about driving cars, self-driving cars, but we've already let ourselves are depending on the computer system. Well, this was apparently a possible in the housing of the ABS, as I understood it briefly from the service people, that could have scraped a trace on the circuit board if it had come off, and that would have affected the ABS automatic braking system. So they did, it's all free. It cost me time, but I'm definitely willing to go do that, and you get a benefit of, service. They actually fixed a piece. I have to give this dealer credit for fixing something he didn't have to, that was under a cowling under the wheel. And that was very nice of them for no charge. But I'm willing to do that. But I think that a lot of these companies are, is again making 1,000 or if you can even, and you can't test that many.
No. I agree. There's all kinds of reasons for this. But,
right.
But one of the fundamental things is this, and I know you love statistics, is that a lot of the standards-based stuff and a lot of the mindset of going into product evaluation is how few samples can I get by with, and to avoid a type 1 error, which is the one where we spend a little extra time thinking something's not safe when it really is. Now, the consequences, this is the key part of Elise's discussion, is that the consequence of making a mistake that something is not safe when it really is inconvenience. We got to spend a little more time and sort this out, right? As opposed to, and most people don't even look at the type 2 error where we think it's good when it's not, because we want it to be good. If we get supporting data and evidence that says, yeah, it's good, the pressure's off. We ship on time. We make our numbers. We, do all the things we're supposed to do and we signed up to do. It's all good. We don't want to go look for problems when we have some evidence or data that supports our decision that it's good. So we don't do the rigorous testing. We don't run halt all the way to failure. We don't, investigate failure mechanisms. Oh, it's only once. We don't do the root cause. All of those kinds of reinforcing activities support this idea of then justifying ignoring and not seeing the safety issue when it's really there. And so that's why we have recalls every day. That's my hypothesis, is that
That's your hypothesis.
Yeah.
I would politely disagree that any company. No, not necessarily.
You
Okay.
know better than that.
We know, okay. We know from the Challenger accident, the Space Shuttle Challenger, that
engineers said, "Hey, this isn't right. We got to stop. We got to slow down.
Right,
this won't work.
Stop it. You can't launch this at this temperature. We haven't tested it."
Right.
And management saying, no, we got to go with this because we've got all this $1,000 million worth of fuel and loaded, and it's ready to go, and all the astronauts, and this is big Christy McCullough's big thing, and it's just all that kind of pressure,
But that pressure is on the people making phones or making a car.
When it comes to safety, though, that, of course, that was a safety decision that was fatal and very tragic. But I just for a lot of companies, I think like this Kia safety issue that I just took my car in for, that they didn't know about this. They didn't test it well enough. They couldn't produce enough fatigue damage in a short enough time for that model, or I don't know how many years of models that they recalled.
Well, I know. I get that. But the idea is it's not, testing is not how you build safety into a product. It's not testing. It's good design practices and good attitude. Same with reliability or quality, is you got to design it in, and it's the entire process.
Right.
Testing's a piece of that. But the issue is
I don't think testing is putting in reliability. I think it's making sure that there are no things that are potential reliability risks. That's all.
Well, let me bring it back
to good design practices, good design for manufacturability, design for reliability. And good design rules are fundamental to making, at least at time zero, the product that works.
Right.
But making a product that withstands fatigue damage and aging, and it's changing materials over time is very challenging.
I know, but that's no excuse for assuming that what we did last time is good enough next time. You've run into so many different organizations where you've said, we need to test the products to failure, understand those failures, and then improve the design. I mean, episode 1 of the show, right? Going all the way back to our first discussion on the show.
Right.
But you've run into organization after organization after organization that says, why are we looking for failures? We're trying to create a product that works. And
that's why I changed it to finding limits, okay?
Right.
Operational, possibly destruct, not always. But that's why, the semantics are very important, because, failure is negative. It's very bad. And we know, you and I know, failure is very good sometimes.
Right.
That you can find stuff. That's how you find it.
Well, that's the point, though, is that the consequence of saying this has got a problem, we need to investigate it, is a conservative error on the side of safety kind of decision.
Yes.
So then we have this, what's the fancy word of the day? Dichotomy, is that we have safety recalls in this country every day. And
yes.
So how do we square that?
Fred,
if we're all being conservative and we're all saying we're making a safe product, when does it stop being lip service, and when do we actually say, no, we got to really investigate this or really understand it or do good design practices?
Well, Fred, you and I know that the process of manufacturing, going from the prototypes, pilot, to full production ramps, depending on the product and what you're talking about, volume, which is cars and phones and everything like that, where you never are at even a 0.1% of what you're going to finally produce. But we both know that in time, manufacturing changes.
Mm-hmm.
Procurement tries to lower the cost of things. They change things. Things change over the production life of the vehicle or the phone or whatever.
Let's use that just as a simple example. Let's say we're going to change a capacitor. We're talking about a capacitor. We're going to go to they're going to a new factory, or we got a smaller one or a lighter one or cheaper one, whatever. And the sales guy says it's the same form, fit, and function. You'll never see the difference.
That's right. Famous last words.
Right. But you and I, when we hear something like that, we go, let's check this. right? Let's spend the extra hour and go check it. But all too often, there's pressure to get the line up and running. There's pressure for reducing costs. There's pressure always. But the decision in those cases is based on scant data or any at all, right? That says, all right, we're going to err on the side of ship it. It's fine.
Right.
Right. And even if only 1 in 100 gives you a safety issue or 1 in 1,000 gives you a safety issue, where do you draw the line going, let's spend at least an hour and look at the chemistry of these two capacitors. Are they compatible, right. For our application? Or is their manufacturing process stable, right? Can they actually make these things? Simple things to check. But it's a little bit
simple?
It is actually. I've done it many times. It takes a couple of hours and sometimes only 5 minutes. The shortest inspection I ever made of an electronic site, I probably told you about this one. I was in Korea, and they had asked me to come in and help them understand a contamination issue they had with their circuit boards. And the taxi drove up into their loading dock area, and a huge cloud of dust from the gravel driveway thing they had went up onto the loading dock, where they had racks and racks and racks of bare circuit boards that were staged from one station to the next station. And they were getting coated in road dust. Yeah. And so I asked the taxi to take me back to the hotel, and I flew back home, and I called them from the hotel, and I said, I know exactly when you do the analysis, what kind of contamination are you seeing? Well, it was consistent with road dust. I said, I think I know exactly where it's coming from. And I didn't even step foot in their factory. I mean, sometimes things are so bloody obvious. Yeah. Sometimes it's easy. But they ignored it for years. They absolutely ignored it. When they were busy, they needed space. The loading dock's a good space. And all it took was one vehicle to go into that gravel area on a dry day, and it wiped out thousands of units, got contaminated.
Interesting. Corrosive road dust? I don't know.
Well, have you ever been to Korea? You can't see. I don't know how many times I've been into Seoul, Korea, and I have yet to see the hills around the place. It is just
I agree with that.
Air pollution beyond belief.
When I went to Shanghai or when I went to China, I remember seeing a bright yellow thing in the sky. It was the sun.
Well, you got lucky. I only saw a street light.
So, it was quite polluted back there in the early 2000s.
Oh, it still is.
It still is probably. But anyway, that's a contaminant. Sulfur has been known to attack silver. I think there was
it'll attack all kinds of stuff.
Exactly. So there has been a problem with pollution actually causing circuit failures because of the chemistries. But
the idea is that
they don't always know this. But sometimes it's
but you and I, if we had contamination, I'm not going to call somebody from the States to come in and tell them what to do, is do a chemical analysis, find out what the source is, and stop it. Right? This is not rocket science. But the idea is that too much of our society is, it's complex, and we'll deal with the issues later. And most of the time, they're not a big issue. Or that engineer doesn't know what they're talking about. They need more experience. Or, it's just a lot of things are biased towards, we want it to work. And then, so that's what we look for is give me the data that shows it works. I even had a boss say, well, keep doing the experiment until you get the results I expect.
Exactly. So that's, that's, and certainly I've been in these situations where you show them the data and they just ignore it and say that couldn't be, like the Varactor that blew up because of lightning strikes going through entire systems of delicate instruments and getting to this tiny little 25 component Varactor for RF tuning, and it's just absurd. The management comes up with these absurd explanations that it baffles the mind how they could create that. But it's for certainly the pressure to continue production, for not stopping the line, for not alerting to the customer that you may have produced some defective components and you're just hoping for the best, or
Mm-hmm.
some of them, sometimes the defect isn't always fatal, and it just causes function of the
Take the
machine not to
batteries
work.
out and restart. Come
Yeah,
back in 10
exactly. There
minutes.
you go. I said the least they could do is put an on-off button to remove the power, erase the memory. You don't have to take the batteries out and put them back in.
Well,
And this is
what's with computer modems or cable modems? The first thing goes wrong is you have to unplug it, wait 30 seconds, and plug it back in. Put a switch on it.
exactly. That's so right. So there are ways that there's several reasons that after the fact, and that products that were thought to be safe can become unsafe through changes in manufacturing, or actually, a mis application of a reflow program somebody did for one run of boards.
Well,
those kinds of things happen.
Well, things can happen, but you know as well as I do is if you have a solid design and it's a robust design and it's resilient to many, many different mistakes, because those are going to happen.
Exactly.
And there's so many things that go on. Well, anyway, that's the thought. It made me think about it is we're also attuned to, well, I've got a little data that shows it's good, so I'm going to ship it. As opposed to, if we make the mistake to think that, we need to do some more work on it. Now there is a boundary, right? You can't say there's more stuff I can improve, because nothing will get shipped. But at some point there's got to be evidence that says it's good enough, as opposed to a gut feel or a can-do attitude or this, that, or the other thing, because we still have recalls every day. And it just baffles me. Yeah, our products are complex. Yeah, our supply chains are really complicated. All these other things that can apply to it.
Right.
Well, that just means due diligence has to ramp up rather than getting out of the way. That doesn't make sense to me.
Right. And that's why, I always suggest for certain sensitive products that maybe a HACCP kind of audit and stressing of certain, as the system changes over time and procurement tries to make it cheaper in manufacturing cost, or they try and lower the cost of manufacturing, that the robust margins, the capability of the product, especially under stress conditions, which show a lot of the weaknesses, is still there. And so that, that you don't know that, so you do know that at least over some period of time, that product is still as robust as the original design that you tested it for.
Yeah.
And so, I'm happy that they do recall it, because, that this Kia problem was addressed and that they came in. I certainly didn't have any problem with it. And I don't know what, they will never publish what percentage they found or what percentage of cars had this actual trace worn off because of the housing or because of some vibration.
Well, some organizations, I don't know.
And you'll never know.
I'm just thinking is that in some organizations, when there's a possibility it could happen, they fix it, right? And a recall might be the way they have to do it. And others ignore it until they have to go to court.
Right, and they may lose big. And I think, what was it?
The Takata airbag sensor.
Right,
they fought
exactly.
that tooth and nail.
Yeah, they fought it, and they're replacing it. But it cost them a lot. It may have cost the company. I think, I don't know if Takata's still around. But
no, I don't think so. So the idea, though, and if you're listening to this, I'm sure there's handfuls of stories or horror stories or whatever that you may have and may not be able to share with us. We understand. But the idea is that to focus on what is the risk to your organization. Is it an inconvenience that you got to go do a root cause analysis and sort something out and fix something? Or do you err on the side of ship it anyway? We got a timeline. And the consequence of getting it wrong is out of whack with the balance in this equation. So take a look at your own organization and how can you help articulate what the risks are? And maybe using risk is the terminology. But whatever your experience is, if you're willing to give us a shout, and we'll keep it anonymous or whatever, you can do that over at accendoreliability.com/go/SOR. And you can find a way to leave us a message or write us a message. Kirk and I and the other hosts of the show are available on LinkedIn or on Accendo. There's lots of ways for you to join the conversation, and we'd love to hear from you. And hopefully you don't get hit by a recall and have to spend half a day at the auto shop like Kirk did.
Well, they were quite good. I must say, the Kia service here was quite good, and they did an extra repair that they didn't need to. So, I don't know that. In fact, to me, that was a good recall because I got into the shop when something else needed to be fixed.
Oh,
they did
yeah.
it for
No,
free. And so they showed that they wanted my business, and so.
And now you're giving them free advertising. So everybody in the Denver, you're in Fort Collins area, Boulder area. Where are you? Yeah. You in the Boulder area?
I'm in just east of Boulder because it's Lafayette, Colorado, which is, you kind of call it maybe a suburb.
Yeah. But you're in the
There's
Boulder.
There's all kinds of little towns.
You're in the south of Denver in the Boulder area.
The Boulder-Denver complex.
There you go.
Metroplex.
It's all going to be one big suburb all the way up to Fort Collins someday.
I'll give it
just mention that Kirk sent you so he gets a free car next week. All right, we'll talk to you later, Kirk.
Yeah, we'll talk to you soon, Fred. Bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.